Okay, let's get started. Everybody want to talk about what they were able to do or attempted last week on this competition? Anyone? Can you guys hear me?
Yep. Yeah.
Any attempts or anything that people were able to try?
I established a baseline for the whole pipeline. I was getting around 0.71. I think so, the score. So that's not much, but yep. I still have to go through the pointers that we discussed last time with respect to the batch size and the tokenization with respect to dynamic batching and dynamic tokenization of a particular batch. And we can, with adding the padding and all. So I'm gearing towards that stuff from the transformers point of view.
Submission, my first submission was like 0.73 or 74 or something as well. And at least so far as I've seen, that 0.7 is where you get to with the standard unmodified networks, but you have to kind of modify the model in order to, at least from what I saw, to get below that. Besides adding in other stuff like the whole FA and the topics and other, there's data related modifications, and then there is also model related stuff in order to get it below 0.7 from what I could see. So you're on the right track. Arto, any submissions from you or any luck?
I haven't submitted anything, but I've made this notebook with low rank adapters. I'm yet to compare the performance when fine tuning, like in full model in a regular way, and with this adapters. If it works, then it should be like just speed up things somewhat. Plus, you can save only the adapter weights and use the same model every time.
So you're still trying that, or I think that's the notebook that you were talking about last week, right? That you were thinking of developing.
I've just implemented it, but haven't completed training runs.
How about you, Jack? Any additional experiments that you were able to run or take the results you saw?
So after my experiments previously, I tried a database, and like my score is still unfortunately quite high. So I've been trying to compare like what I'm doing with like a high scoring notebook. And I've been looking at this notebook by Abhishek. So the score for that notebook is about 0.62. and he's using like an ensemble of DBERTA base to achieve that. So I'm just like to see what he's doing that I'm not doing, and then trying to apply those differences to see if it will improve my score.
So you said he's using, when you say basic notebook and using ensemble, you mean he's ensembling different folds of the database? Is that what you mean?
Yeah, okay. I'll show you. So I've been looking at this notebook by Abhishek and Thakur. Is it? So if you look here, like, oh yeah, so if you look here, like the score is 0.627, and the code is in this main.py script. And if you look here, he's got like an ensemble of 5 models, I guess, from 5 folds. And oh no, he's using DBERTA large actually. Okay, so maybe I do need to go to DBERTA large. Yeah, I guess that's a big difference I need to make. But I've also been looking at other differences, and like what's surprising here is like the batch size is only 2, and he's not really accumulating the batches. And I don't know, it seems like a very, very small batch size. Yeah, so like I've been looking at the script, and I've noticed several differences between what he's doing and what I'm doing. And so like one of the differences is the way he uses the dropouts. I don't know if you guys been using like these like different dropout branches. So like him, I'm also using 5 different dropout branches towards the end. But he also has this additional dropout, which he applies before these 5 dropout branches. As you can see here, like, sorry?
What is TEZ here? TEZ?
TEZ, I think TEZ is a package by Abhishek. It's just like a his own framework for PyTorch, basically. I guess you can think of it as like Fast AI or PyTorch Lightning. I think it's available.
Yeah, he has the library installed. Or
Okay.
as input, if you look above, right, just above where your pointer is, it says he's installed that as input as well. Above that,
Okay.
in the input section.
Yeah. Yeah. Anyway, it's available, but it's public, so you can use it if you want to. Yes. So like so after the transformer, so the output goes through a pooling layer. I think he's just using a simple mean pooling, and then after the pooling layer, he uses this dropout layer first, and then it branches out into these different 5 dropout layers here, and then he gets the logits from each of these 5 branches. And so here's another difference between what he's doing and what I've been doing, which is taking the logits from these 5 branches to make a prediction. he takes the average of these 5 logits and then applies the softmax layer. But during training, he doesn't actually use these logits. He takes the 5 logits, pass each of them through the loss function to get 5 losses. And then he takes the average of these 5 losses and then do the backward propagation on this instead. So this is what I'm not doing. And so I will try this and see like if it improves things. Yeah, and also some of the other differences are like, yeah, so the mean pooling layer, at the moment, I'm just taking the CLS token. So I guess I can add a mean pooling layer. And also for the optimization, he applies no weight decay to all the bias parameters and all the layer norm weights parameters. And yeah, this is something that I'm not doing, and which I will also try.
Isn't it done automatically in PyTorch Lightning? Maybe.
Oh, is it? Okay.
I don't know. I don't use PyTorch Lightning, but I know that, for example, Hugging Face Trainer would do that, and yeah, some other libraries kind of handle those kind of things. But maybe in PyTorch Lightning you need to do it. I don't know.
So is it desirable not to have any weight decay for these two under all circumstances, irrespective of like the type of task, the type of architecture?
Well, for transformers, it's definitely, I think, default not to decay this. And yeah, I think in vision models as well, some of the parameters are not included into this weight decay function. And also, if you are using the transformer models, I think there is a utility function for that. It's called something like get parameter groups or something like that. And that would give you like a parameter groups split it into the parameters with and without weight decay. So you don't need to implement it like manually. You can use that.
Okay, so maybe I'm already doing it. It's just I didn't know. Okay, thanks. Another thing is I've been using PyTorch's AdamW without any learning rate scheduling, and he's using the learning rate schedulers from like one of the, or produced by one of transformers functions, like something, I think it's called get linear schedule with warmup, and he's not using any warmup. So yeah, I'm also gonna try to use some sort of schedule. He's using max length 512, and I'm using like a longer max length. So, and I'm getting like poorer scores. So I will also try reducing my max length. And also he tokenizes everything beforehand, not instead of like doing it on the fly. I'm guessing this just speeds things up instead of improving the performance, but I'm not sure. Yeah, if I have time, I might also try this. One thing with like the learning rate scheduling is I actually came across just like Googling, I came across this paper, which, I mean, I didn't read through it, but it seems like just reading the abstract, it seems to suggest that when you're training transformers, it's quite important to have like a warm up in your learning rate scheduling. Apparently it has something to do with the layer norms. And given that Abhishek has not been using any warm-up, I might try to add some warm-up to see if also improves things.
It might also be a good idea to try this, how it's called, rectified Adam or something like that. You know, there is a variation of Adam optimizer. It performs better than regular Adam on some tasks. You can use it from
Is it just
PyTorch.
called it's just called rectified Adam?
Yeah, I will. You let me Google it and send you the link to PyTorch docs.
Okay. Thanks.
It's R Adam, I think, in PyTorch. Yeah, let me find it.
Okay. Yeah, there is something called R-Adam. Okay, thanks. I will try this. Although I don't know what the difference is between this and Adam.
Oh, so it also deals with this instability early in the training, and yeah, it's basically has a somewhat similar effect with like warm up, but maybe more maybe more sophisticated approach to handle this like early training noise in the gradient, something like that, if I remember it correctly. But yeah, just from like experimental perspective, sometimes it showed better results, sometimes not. But yeah, I think more often it's better than Adam on NLP tasks.
Okay, thanks. And it's from quite a recent paper. Let's see. Okay, like I also, so I noticed that Abhishek is also using this, he's also using this text pair that Shrivina's had mentioned last week. And so I kind of just like sort of try this out in a notebook to see, you know, like what exactly is happening. And so basically I took a piece of text from the competition data. So I fed it through a tokenizer the usual way. So I'm getting some token IDs, token type IDs, O0, and the tension mask O equals 1. And then I just kind of give it to the tokenizer again, and then using it as the extra text, well, like as the one of the arguments, and then so it looks like basically what it's doing is, if you see here, like the first token is 1369, and the last one is 260. So here is 1369, and then 260 separate a token, and then it starts again. And so it looks like in terms of input IDs, it just repeats. It kind of just tokenizes the extra text and then append the input IDs to the token IDs of the main text. And I guess the difference is with the token type IDs. So the main text, it will have a type ID of 0, whereas here, like the extra text that you supplied will have token type ID equals to 1. And I think this is what separates the the main text from the extra text. And I also, so basically, I also created just a model and then passed this input through the model. And then I tried passing this through the model. So I tried it for DBERTA small, and essentially the output logits are identical. So I guess the DBERTA models, they just ignore this difference.
Yeah.
And
yeah, there is a parameter in so if you have, do you have like a notebook with DBERTA running? Or yeah, I can
not really.
maybe just quickly share.
You want to share? Okay.
Yeah, just for a moment, maybe. Let me, okay. Yeah, so can you see my screen?
Yep. Can you increase the size just a little bit?
I will try to do it. I'm not sure how would it. Okay, it works nice.
Yeah, that's good. That's good.
Okay, so here in the config for model, so this is a configuration for DBERTA small, and there is a type vocab size parameter, and if it's 0, as it is for DBERTA by default, the token type IDs are ignored. But if you would try, maybe if you set up it, if you set it to some other number, I haven't tried that, but in that case, probably it will just learn the token type IDs from scratch. It can probably mess up depending on how you initialize it. Yeah, so if you add this token type IDs vocabulary, basically, it probably want to initialize it to zeros, but I think you can enable the model to learn it. But by default, it is not used at all. So if this parameter is 0, the model just ignores token type IDs. That's what happens like internally in the code.
I have a question, and Jack. Since at least a couple of people have commented that with DBERTA and providing the essay text, which is the text that's provided as kind of the second part, if you will, of the combination, is it simply a case of, as you mentioned, Raju, and as you showed right now, the DBERTA model fundamentally doesn't do the, it's not based on the second sentence prediction, and therefore doesn't use inherently the token type IDs. But is it the case that it, and from what shared, it seems like the text is just appended to the first text sequence, and with some kind of a non-separator, because you don't want the model to think that the sentence has ended by having SEP there. So you stick in whatever Jack's notebook showed, and thereby it just thinks that it just thinks that it's a long sequence, but with a non-SEP separator between the two. And that somehow helps provide more context for it, meaning for the model, to better parse the first portion, which is still what we care about, which is the sequence of things that we append, like discourse type and discourse effectiveness and things like that. But the model does have the additional context of the essay data. And the other thing I was thinking of is most of the essay data, in my opinion, would probably be getting chopped anyway because of the size, right? Because by the time you stick discourse type and discourse effectiveness, and that itself is pretty long. And then the essay is obviously quite long in many cases. So it would be getting chopped because there is truncation that is turned on. So in any case, even if it were relying on the essay, can't rely on the entire thing. It should be getting a chopped value. Is my rambling make any sense?
Yeah, so I think to the first point, the separator between texts, if you provide two texts, it just is the same as you use like default separator token. Yeah, so regarding the context, so I was thinking that for different types of discourses, having access to the full essay, it might be more or less important. So for example, you can assess the quality of lead just without probably like looking at the whole essay, right? But for some other types of discourses, if rebuttal is adequate, it might highly depend on what came before it, right? So we probably want to have the relevant part of the text to predict if the rebuttal is effective, right?
Yeah.
Yeah, so those are my thoughts.
My point is, I agree with you that and additionally, at least in the model that I was talking to last week, he uses the topic that he generates based on analysis of the essays from the 21 competition as well, right? So the topic might provide enough of a context for the lead, but like rebuttal or evidence or something like that, then you may want a little bit of the essay context to provide you better context. It leads me to the question, Jack, do you know whether the Abhishek's notebook uses any kind of topic knowledge, or he doesn't at all use that?
No, he doesn't. He just uses the discourse, text, essay, and type. That's it.
I see. Yeah, because the notebook I shared last week, and I kind of I'm kind of in between two things. I ran it, what I shared last week, and got it to work. The thing is, it uses the Berta base model, but then the corresponding inference notebook, I haven't submitted that yet, but the inference notebook that the guy shared actually uses the Berta v3 large model, just like Abhishek, except that he uses the additional topic merging that I mentioned. And, as you were talking, Jack, I checked, he does use a cosine learning rate scheduler and a small amount of weight decay, like 0.1 or 0.01. And uses a pre-trained, meaning a Colab v3, the Berta v3 large model trained on Colab because and 5 folds, because he says training 5 folds with the Berta v3 large, it just runs past what Kaggle allows you to do, which is about 8 or 9 hours to train that thing, and it takes more than that. The Berta v3 base, which I trained, itself takes, when I ran it, I think each fold takes about 1.5 to 1 hour 45 minutes. So that itself puts you, right at the very edge of using 8 or 9 hours or whatever. So by the time you use debug v3 large, then it no longer works on Kaggle. So if you are running debug v3 large and trying, either you would have to reduce the folds or do it offline on Colab and then get the model, trained model into Kaggle. But his results using debug v3 large thing I shared, the overview or that corresponding inference notebook gives a score of about 0.624. And he uses topic and he uses otherwise most of what I shared last week.
How do you guys decide on the epochs, the number of epochs for the fold, or if I'm taking the whole model as a single end-to-end, how do I say it? Single end-to-end pipeline. So how do you decide on the number of epochs there?
Do you mean like how to choose the number of total epochs to train for?
Yep.
I look at what others are doing.
Okay.
I don't really know.
And I think what mine determines ultimately, well, the general comment I would make is, at least in, I'd like to hear Artu on this, but generally I've seen the number of epochs, because remember, these are pre-trained models we are using and these are very large. So generally I've seen a fairly small number of epochs being used. I haven't seen very large numbers, somewhere in the single digits, even in the mid to high single digits is very much. So I've seen most people use between 3 to 5. And as Jack just said, that's a good indication. But the other thing which I generally have observed and people have commented is, if you're running on Kaggle, you're ultimately limited by, as I just mentioned, the number of hours that you can run with any of these. So that limit doesn't hold for Colab. You can run, if you're paying Colab Pro, then you can run for a very long time as long as you're active. But in Kaggle, people also found it by, I have to fit the whole thing. So if I'm running, like I just said, if I'm running 5 hours, if I'm running 5 folds, and there is an 8-hour limit, and each fold has to finish within certain time, and that time bounds how many epochs you can train for. Does that make sense?
Yep, it does. Thanks. Yep, and
Sure,
think so that. Yeah, Jack, go ahead.
Go ahead. Okay. So actually, you can train beyond 9 hours. You just need to make sure you have checkpoints frequent enough that just before you're timed out, you have some checkpoints, and then so after your notebook is timed out, you can still download that checkpoint and then upload it as a data set, and then resume your training, but loading the checkpoints. So it is possible to train on that, yeah, but it is a bit more tedious, I guess.
Yeah. So most people I've seen, kind of take the approach of fitting it in within what Kaggle supports, and if not, going to Colab to do the work unrestricted and then importing the results. Artu, have you seen very large things other than by any of the, I'm not talking about people working at Google or Facebook or any of these places who have, practically infinite compute resource on their fingertips, but in terms of Kaggle or any place else, have you seen very large number of epochs of training of these Liberta, V3 Large, or Roberta, or any of these models?
Yeah, I think that for fine tuning, it's never a large number of epochs, because basically these models are very easily overfitted on even like medium size data sets. So yeah, I think most of the time people do something like up to 8 epochs, and often the best epoch wouldn't be the last one. So that's what I've seen, at least. Yeah.
Yeah, that makes sense, because actually all the dropout things that Jack shared, and like I mentioned, I think I mentioned it last week, but the complete overview notebook also uses something he calls some graded dropout, or he has a reference to the paper that I showed as well. There is a link there.
Yeah, so in this competition, they use the validation loss as a measure, right? Not the accuracy, and that basically also change things, because it's often the case when you keep training, the validation loss starts increasing, and but accuracy still may improve. And as far as I understand, it happens because like models starts making some very confident predictions on some wrong confident predictions, right? And that will not affect accuracy, because the prediction, it was wrong, and it remains wrong, but more confident. But the validation accuracy or validation loss, it gets higher and higher. So here you probably would want less epochs. And actually, this adversarial training might be a very nice thing here, because when you do adversarial training, most likely the validation loss will not increase towards the later epochs. So
yeah, that's something I was thinking about, because in fact, there's a discussion, I forget in where I saw it, maybe even in the discussion posted. No, I think somebody else, if I recall correctly, I could be wrong on the name, but the guy called has a username of, I think, CPMP, and there's a discussion when he posts that about overfitting, and there's a discussion of what is meant by overfitting. And in this instance, most of the people talk about, and in fact, I think even the generic definition, if you will, of overfitting is what you described. That is the phenomena where, as you continue to train, your validation loss goes down. I mean, your training loss goes down, your validation loss goes down, but then at some point, the validation loss begins to turn up again. And at that point, in fact, I think even Jeremy says that, typically you can continue to train a little bit beyond that, because accuracy goes down. If accuracy is your metric, it continues to go down a little beyond when the uptick in validation loss happens. But to your point, at that point, the guys in the discussion are saying, hey, I have overfit because my validation loss at this point is increasing. And in this case, that is the metric. So as you say, people are saying, and that is part of the reason people are using all kinds of variations of dropout and stuff to try and address the overfitting. But I think what you mentioned of this adversarial, the last time what Steve was trying to get implemented, adversarial weight perturbation, if I recall correctly, right? AWP or something. And implementing that here could be a way to bounce up, because again, most of the notebooks I have seen which are public get you to about 0.6160, something in that range, for a single, I'm talking about a single model ensemble. By that I mean, just ensembling different folds with the same model. But anything beyond or below that is typically with multi-models, using Roberta and Diberta and a few other models. And then, so you're ensembling at that point, not just folds of a single model, but folds of different types of models. And even that isn't the best score, because the best leaderboard scores are like 0.56 in this competition. So they're doing something more than what what everybody else is doing. And one of their tricks would be what you're talking about, Artu, of this adversarial weight perturbation.
Atul, are you going to like with your adapter code, like is it something that you will share like before or after the end of the competition?
Oh, I will share when it's ready. I don't think it will, like, I don't really have time right now to, commit to this competition. So I don't think I will have any like good submissions. So I will, when it's ready, I will share it. I just need, at this moment, I just need to test if it works as expected. And I mean, the accuracy
is it based on some
be,
paper?
Yeah, I can send you a link to the paper I've been implementing.
Can you post it on Slack, Kato?
Yeah, I will post it. And there is another paper which was published approximately at the same time. I haven't tried that yet in any project, but I guess it should be like compatible. So you can basically mix different adapter modules. So I've sent a link. Yeah, I will. Let me.
You can post it on chat, or even if you don't find it right now, you can post it in Slack later.
I've posted one link in Slack, and I will edit the message. We'll add the other one now.
Great, thanks.
Yeah, no problem.
Thanks. Sure. That's like, have you tried this other method you mentioned last week, where you analyze like the essay instead of the discourse?
No, in fact, I wanted to get the base thing working, and before I started going down that path of, you're talking about the suggestion that the guy had of tagging the discourse type within the essay and then using that. Is that what you're talking about?
Yes.
Yeah,
I think
no,
it's like quite elegant idea, like solution.
Yeah, I wanted to kind of spend some time, what he's suggesting, and no, I haven't done that yet. I wanted to just get the basic thing working, submit it, see where it ends up, and then go from there. And yeah, that's something at least worth taking a shot about, but we'll see whether I get to it in the coming week.
So I was thinking about like a different direction. So what if we fine-tune a separate model for each type of discourse? Have you seen this like tried? And I don't know, the results with this approach, because you know, the criteria for different discourses to be like adequate or not are very, very different. So it doesn't really make necessarily make sense to train a single model to classify all types of discourses simultaneously, right?
So, so you're saying that you build a model per discourse type. So since there are, if I recall correctly, 7 types, so you would have 7 models. And then how do you, like, what's the way to, what's the pipeline for the model or the overall end-to-end thing? So you would sort, depending on discourse type, you would send it to the different models?
Yeah, that's the idea. So the discourse type is given, right, in the test set as well, and there is no problem with doing that. So the inference for different. I was just thinking it would be like a good baseline for whatever you might try to do later.
So you would get but in the output, so you would be getting like, I'm just trying to think of the structure of the model. So you'd be getting like 21 outputs, meaning, 7 discourse types, each having 3 effectiveness. So each of the models would be outputting 3, again, basically, instead of single model outputting 3 and all of the discourse type going into it, you would have 7 models, each outputting 3 values. Is that what you're thinking?
Yeah.
Interesting. No, I've not seen anybody try that. And then you would still do the folds and kind of predict and do the averaging per model, I guess, right? Per fold. That's an interesting thought as well. But no, I have not seen anything in the discussions, at least that I've gone through, or the code that attempts to do that.
Yeah, and it might be useful, for example, for pseudo labeling. Like we have that larger data set from previous competition for this type of data. And if you can, for example, if you can get with a specialized model better performance, then you can use those models for pseudo labeling that data as well, and then training like maybe a single model for effectiveness, or that's one approach. Also, you can have if you train adapters, you basically have one large model, and you have like a small adapters. So the like specialized weights are not large at all. So you will have so that also helps, like in this case.
Yeah, I haven't got my head around the adapters idea, so I think seeing your notebook might clarify a lot of things in my head. But to your first comment, though, of the pseudo labeling, in fact, if you can, if people take a look, I haven't fully grasped it myself. That's on my list of things to dive into. Is the guy who implemented the notebook I shared last week, he does, I think, something akin to pseudo labeling, because he predicts the, I think the prior competition was not, was based on predicting the discourse type. So it's like a named entity recognition type of competition, because you were, I think, given a whole bunch of discourse types and you train and predict the uses. He does discourse effectiveness prediction on that data and then uses that data as part of his combined model for this competition, which is kind of the pseudo labeling task you're talking about, correct?
Yeah, that's what I mean.
Yeah. So
Ato, I
he
don't
does
quite
that.
understand. Like,
Excuse me?
yeah. So
Shri,
with pseudo labeling, like if you train a single model for all discourse types, I mean, you can still do pseudo labeling, right? So do you mean like if you have a separate model for each discourse type, it will be even better for pseudo labeling? And
Yeah,
if that's the case, like why?
I'm thinking if you train a single model for each discourse type, if it improves the performance, then it will help with pseudo labeling as well. So that's based on the assumption that a specialized model will perform better than like a general model. But it's
Okay.
So it's not a statement; it's just a theory.
Okay, yeah. So I guess you think like if you were to try this, it's something that should be tried sooner than later, right? As you mentioned, like they would give you a baseline.
Yeah, so I'm thinking that like looking at the results for specialized model and comparing it to like a generalized model would give you some kind of reference if the generalized model, if you lose the, so for example, so here in the generalized model, you convey the information about discourse type by just adding it as text, right? Or as a special token if you choose that. And by the way, which one do you use? The discourse
Just
type.
as text.
Okay.
And separated with a separate token, yeah. Yeah, okay. So yeah, I guess like yeah, I guess this is something that could be tried because it's quite simple to implement, right?
Yeah, and yeah, so probably it's harder for the model to to classify the to do this classification when the this discourse type is just some text, as compared to classifying the discourse, knowing that it's always that type of discourse. Well, yeah, so that's the idea. Yeah, it kind of it just seems obvious to me that it's a thing to try, and I was like, so I'm kind of surprised it haven't been tried. Maybe it doesn't work in this case for some reason, or it doesn't help. Yeah, because it's kind of something you would obviously try.
Or maybe it works really well. That's why people don't want to mention it, like especially the people that.
Yeah, maybe, but
Yeah, the
Yeah,
the other thing why, again, it may or may not work, as you said, until you tried, but one pointer that may point to it being your suggested approach being a good approach is because the number, I don't mean the proportion, I guess I'll have to check the proportion, but if you look back at the, let me share my screen to show you that's what I'm talking about. So because visually, I think it's an interesting point that may or may not contribute to what you said, but I think it's relevant. Let me know when you can see my screen.
Yeah, we can see.
Yeah, we can see it.
Okay, so if you look at it, this is the effectiveness distribution per discourse type. So to your point, you can see in claim and evidence that the numbers are quite high, although the thing that you can also observe is, I haven't converted that because these are numbers, right? So these are sheer counts. These are in proportions, but the proportion seems roughly the same, right? Although I haven't actually calculated the proportion, it would be fairly easy to convert from the count to proportion. But for example, in case of the lead or the position, the numbers are much smaller, right? Whereas in case of claim and evidence, the numbers are fairly high. But the proportion seems, in all cases, adequate is the most, effective is kind of second, and ineffective is 3. And, we see the slope of these graphs are not exact, but kind of the same. So I don't know. I thought that's relevant to what you're suggesting, right?
Yeah, I was looking at these numbers as well. So yeah, that's for example, there are not too many rebuttals at all, so that can be kind of problematic. But on the other hand, when you train the generalized model, it might be even more so, because like the model should basically pay most of its attention to the claims and evidences, because those are like very numerous compared to other ones, right? And yeah, for example, it would be interesting to have a look at the numbers, like evaluation of generalized model by the discourse type. That's, if you have a model, that's something you can do easily, but it would give you probably a good understanding if there are some like weak types for that particular models, right?
Yeah, actually, he does do some analysis. To your point, I might go back in, and I've run this notebook myself. This is my run, and I can go back and modify. He does do some analysis, and he points out certain things, although, neither he and I haven't had the time either to sit down and think about what you could do to address the shortcomings. What he does point out, for example, he has a confusion matrix, and it's clear, see here, he has a confusion matrix per discourse type, right? And, one of the things, and I had some notes about this, I think most of the confusion is between adequate and ineffective. That's where you have most of the problems.
Okay, so here it looks like for some discourse types, it is very bad at predictive ineffective, right? Because so here, for example, for the I cannot see what. Oh, this for position, right? So it more often misclassifies the ineffective for adequate, right? And the same for claim. So for many.
Yeah, as I said, what he does identify is ineffective to adequate split is where most of the problems, errors occur.
Mm-hmm.
And that is true regardless of the score type.
Yeah, I see. Yeah, but for some of the types, it's very strong. So, for example, for counterclaim, it's almost always predicts the ineffective. Yeah, that's interesting. Oh, so
no,
yeah,
counterclaim it almost never predicts ineffective, right? Because predicted label is 0, ineffective is 19 predicted tables for counterclaim, whereas the actual and this thing, whereas here the predicted for this is for counterclaim, the ineffective actual is 19, predicted is 19.
but
Predicted but adequate predicted is 184, whereas I think this 184 should be here. So it predicts a lot of ineffective as adequate.
Yeah, so it's interesting that like how it will look in terms of loss, because, for example, if we have like almost similar numbers in probability of being ineffective and adequate, although the like accuracy would be low because it predicts for example, adequate for ineffective, but in terms of loss, it would be okay because those would be like close, and because we optimize for the loss value rather than accuracy, that might be like cause of this pattern, right?
Mm. But since the metric is the same thing that will be used for the judging also with respect to the test set, because based on what you said, I was thinking, is there a better loss that you would use? In this case, we are using, because it is the loss as the metric, or the metric as the loss, either way, but the loss is differentiable, that is, the metric is differentiable, so we are okay with using it as the loss, right? And I was wondering whether using a different loss will get us a better result, but that will not be the case because the test case metric is also this, correct?
Yeah. So also there is some like weird formula for computing the actual metric, right? So it also uses the minimum of log loss.
I think it was just the average log loss, right? If I'm not mistaken. I'll come back here, but
okay, so there is an efficiency score and
oh, the efficiency, you mean the efficiency competition is basically how efficiently you predict. That's not related to the score here. Is that what you're talking about, or are you talking about something else?
I'm looking at the like efficiency price evaluation page, and
that is, yeah, that has to do with how computationally efficiently, meaning using less compute, do you get the right results? That's what efficiency computation is about. Because
Okay.
they're trying to counteract, like I was just saying, even our single model is actually, as Jack was also showing, right? It's an ensemble of 5 of the same model, but the best performing results, even in the prior competition, were ensemble of different kinds of models, like Roberta, and like the patent competition was SBERT, Roberta, I forget, Tiberta, and so on. And they are trying to say, well, that's one way, but is there a better single? I should be careful in saying single model because it doesn't really have to be a single model. It could even be an ensemble, but anyway, the correct thing they're aiming for, or the more precise statement would be, what's the most efficient way of getting there? They don't care whether you use a bunch of smaller models, or a single relatively large but still efficient model, but they want it to be efficient, meaning less compute. But that doesn't have to do with the loss evaluation per se. It has to do with the computational efficiency of your model.
Yeah, I
But
see.
here-
I see now that it just in this efficiency score, they scale the log loss by some coefficient, and I was confused by where it comes from.
Okay, I see. Oh, how they evaluate is by scaling. Okay, I see.
Yeah,
Okay.
yeah, but they do not scale for the main competition. They do not scale it.
Yeah.
So they
So,
want to,
to your. Go ahead, Mike.
yeah. So they want to reduce the latency of the model. How much time it takes to infer for a complete cycle when the request goes through from a general to a more specific part of a particular model. Which can also be thought of like a hierarchical interpretation with respect to the general model is at the root, and the more specific models are the leaves of that particular root. So I was thinking in that way. Is my interpretation correct here?
I'm not really sure. I haven't looked at the evaluation of the efficiency, but when we looked at it previously, my simple takeaway was they're just trying to, to your first comment, yes, they, obviously if you have a more computationally efficient model, as I stated it would be, the expectation is that it would be low latency, but I have to think about whether the two statements are equivalent, but I think they were after efficiency. How they decide the efficiency, I haven't recently looked at how they compute the fact that your model is more efficient. And that's where Arto was looking at and he was commenting on it. But my point is, back to what Arto was commenting and we were discussing is this thing about, per discourse type, whether that's a good, I haven't seen it. It seems like it's a good, definitely attempt can be made about trying to see whether if you do it per discourse type, whether these results can be improved. And because it is just dealing with the discourse type, it gives you any better results than a single model. And And to your point, Ato, he also discusses, or he shows, see, most of the confusion, it is confident but wrong, which would mean, as you said, that the loss would be higher, right, is between confusion of ineffective and adequate. But the thing which kind of, to me, goes in the opposite direction to what you said, and it may not give us, of course, we won't know until we try, but just debating it in the abstract or in theory, going in the opposite, something going in the opposite direction is the fact that this seems to be the problem, regardless of the effectiveness of the, regardless of the discourse type. You know what I'm saying? That this difference of struggle between effective and adequate is true across all discourse types, mostly. It's worse, some it's better, but in all cases it's bad compared to the ability to distinguish between effective and ineffective or effective and adequate. So in effect, and I haven't thought about this more, but it is, I listed it down, is what or how can we help the model make this distinction a better way? And as I, was offering the conjecture last week to Jack, I personally thought that, and it's hinted at in one of the discussion threads, I personally thought that that is where the topic help, maybe, because what the commenter had said was, when you know the topic, then the topic is an indirect proxy for the grades of the essays. By grades, I don't mean the grades assigned to the essay, but the grades that students are in when they write the essay. So apparently some topics are given to lower grades and some topics are given to higher grades. Higher grade level students and lower grade level students. So if your topic falls into higher grade level students, then the conjecture is that there may be, I haven't done this analysis, but maybe that analysis, if it can be done, can also support the conjecture is then if for higher grades, if you have more even distribution of ineffective, effective, and adequate, versus at lower grades you get, more of ineffective and adequate, then the model may be helped by giving it a topic hint or a topic actual, not hint, but the actual topic, which in turn is a proxy for this difference.
Mm-hmm. Yeah, that totally makes sense. And how efficient is this topic BERT in identifying the clusters? I think Jack showed some results there last week or before, right? I'm curious.
I don't remember the time exactly, but it's fairly quick. I would say maybe 30 minutes.
Yeah, I was asking more about how good it works. Have you evaluated somehow if it identifies the topic robustly, or how good is this?
Okay, so I have been using the topics, but I don't simply include the topics as the input string. I kind of use it to group the to group the essays and then get the discourse text from of the same type from all the essays, and then append that in the model input instead. And so I haven't really noticed the big advantage, but I was using just a small subset of data, and debug are small, so I cannot be sure like if it's better to have it or without it. I guess I will know like when I start using debug are large or like more of the data set.
Yeah, I haven't tried with, because there are two questions, right, that you asked, or that would be interesting. One is just how effective is the topic word itself in identifying the topic, and the other is how much does the topic sorting actually help the results in our problem. And the latter could probably be handled. I haven't tried it. I could probably run an experiment. I haven't, run these variations, but then I would have to do a base or whatever this model that I'm sharing right now, with and without the topic headings gathered from the, because the topic headings originally are generated for 2021, then he also uses it to generate it for 2022. And the potential experiment to run there would be with and without using the topic headings to figure out what difference is, what the result difference is when you use topics versus not. But the guy, and I'll look into whether the guy says something about the extent of the impact on topic, but because he says he has used the topic because he found that it gives him better results from experiments that he ran offline, but I'll check whether he has any details on that. Fascinating, but I think we have about 2 weeks left in the competition. And I think, as Jack is saying, definitely there are some techniques that the leaderboard folks are using that will come out much like in the prior competition with respect to the data, with respect to the model, that I think aren't widely known at this point, because the best notebooks I've seen publicly that you can kind of apply and get is in the 0.61 without multi-model ensemble. That is a single model but with fold ensemble. But the best results on the leaderboard are in the 0.56 kind of. I think 0.560 or 0.56 something is the best results. And what is fascinating, I think, from what Jack shared in the last couple of posts, and I haven't looked at it last week, but from what he showed previously, it seems, at least in this competition, that some of the people at the top of the leaderboard are also at the top of the efficiency leaderboard, which means that they are not doing a whole bunch of ensembles to get their high scores. But at least if they are, then they're doing, additional things, maybe like, distillation, student-teacher training, or whatever, to keep the eventual models small. Sorry, exactly.
If you have time, I've dug out an experiment I did to compare like using topics and without using topics.
Yeah, go ahead. Yeah, sure.
So basically, so the two experiments are jumping butterfly and driven gorge 58. So these two, are identical in that I'm using half of the training samples, and also I'm using dropout and freezing some layers. And the only difference between these two is that with jumping butterfly, I'm just using the type separated by the text, separated by the essay. And with driven gorge, I'm using the type separated by text, separated by some topics information. And so this is using the Berta small though. And so if I train them for 5 epochs, so using the essay text, I get this. And if I replace the essay text with topics information, I get this. So I guess like if you just look at this, then you would say that topics, it doesn't work as well as essay. But if you look at like the final loss values, here the training loss using topics is 788. And the final validation loss is 0.8254. Whereas if you're using essays, like your final training loss is 0.42, and the final validation loss is 0.7. And yeah, so like in that sense, like if you use essay text, it seems like you're overfitting more than if you're using topics information. But in terms of
wouldn't the
validation
comparison
values,
actually be for including both the essays and the essay topic, and then including the essay but not having the essay topic? Because as I understand it, the experiment you're sharing the results for is, in one case you include the essay, in the other case you just include the essay topic but no essay, correct?
yeah, that's the experiment I did. But I really should just like add the topics to the essays as well.
Right. And then that would give you, or, essay with essay topic and essay without essay topic. And that would give you just the importance of the topics.
Yeah. But I guess you would have to add the topics before the essays, right? Because it will get truncated, at some point.
Oh yeah, that's why what he does in the when he does the tokenization is he first adds the essay topic to discourse type, discourse whatever, the string separated by spaces, blah blah blah, and then adds essay as the second piece. So if there is any truncation going on, it's the truncation of the essays.
Have it been tried like in a previous competition we discussed, including so you can include the discourses from the same topic, from the same type, like at the end, right? So give it a bunch of other discourses, like it was done in previous competition.
But wouldn't that in this case confuse it more, because it would then, because are you suggesting provide the same type of same discourse type but add more to the end?
Yeah, I don't know.
So I used that's the results I've just shown you. That's what I've tried with the topics. So after adding the topics, to each sample, I then group the samples by their type and topic. And then I grab the discourse text from each of these topics and kind of just join them up. And then append that to the model input. And also before doing that, I sort all the samples by their topic probability. So I'm only using like I guess yeah, I guess if you're using, so for each group you will have a number of discourse texts, and if you don't want to use all of them in your model input, then you will use the most probable texts belonging to each topic. But yeah, that's how I have been using the topics information. I haven't just simply inserted the topics strings into the model input.
Oh, okay, yeah. So
yeah,
I see. So basically, you was trying. I was thinking similar to the previous competition, right? So you just add.
Yeah, the magic trick.
Yeah.
But I don't know. I mean, to me, I'm not sure if it makes sense. It kind of makes sense, but I don't know.
Yeah, it's kind of maybe it will be kind of useful if you take. So we can use the data from training set and give it examples, right, of adequate, ineffective, and effective discourses from this type, from this topic. So that's kind of what you can try to do, like do a few shot instead of basically fine-tune model to do a few shot prediction and then do few shot prediction. So you can use the training set at inference time as a source of examples of discourses.
Yeah.
Yeah, that might be. And you can give it labels, right? So you can. Yeah, that's something maybe to try as well.
So I'm not sure exactly what you mean, but like the effectiveness is not available at test time, right? So how would you be able to?
Yeah, but it's available for training set, right? So we have training samples, and we can use it at inference time as a source of examples, and as well as at training time too, right? So we would basically sample the discourses from training set that match the topic of current of current discourse, and give it like say too adequate to ineffective into effective discourses of each and just labeled from the training set. And
so you're saying attach that to your input for tokenizer, attach couple of examples of the same discourse type, but with varying effectiveness, like one example or two examples each, and stick it.
Basically, very similar to how for example, GPT-3 does few shot inference. You just give it a list of I like it and the sentiment is good. I don't like it, the sentiment is bad. I don't really like it, and then you have like it to generate the response, and that how it does few shots. So we can do something similar here, right?
Interesting.
Yeah, thanks. I'm not entirely sure about the details, but I'll try something.
Yeah, sure. It's yeah, it's from idea to implementations that it can actually be useful. It's quite a long path, and yeah, I not always make this way. So yeah, sure.
Last time we also discussed about gradient accumulation. So has anyone tried that?
I did try it. So like for me, it didn't really change anything. But as I mentioned, I was using a very small subset of the training data. And yeah, but it
Yeah, and
usually helps. I think it's quite a general technique.
Yeah, the whatever the notebook I shared last week utilizes accumulation. And I think if you were to use Libeta V3 large, then you probably, or I should say it this way, the notebook I shared last week uses Libeta V3 base, and even that base to get it to run within the time constraints that I mentioned without doing what Jack said about, like saving and restoring and all that. If you wanted to work within Kaggle constraints, then you would have to do, I think, gradient accumulation, because he has gradient accumulation implemented. He does have it as part of his configuration.
Oh yeah, so do you know what's cool? Like, you know how I applied all those memory saving techniques? And what I've noticed is like, so using Libeta small, my batch size is 38. And when I change it to base, Libeta base, the batch size only goes down to 34, which is like, which was quite surprised. I was expecting the batch size to be a lot smaller. So I'm thinking maybe it's because of those techniques that I apply.
Yeah, the gradient caching might to do with it. For example, for Libeta small, it might not be very like useful because it's
right.
Smaller, but when you go to larger models, it can be really what enables it to work on
that's
a smaller
cool.
GPU. So.
And in fact, Jack, if what you shared, that guy, Abhishek's notebook, if he is training it on Kaggle itself, then that might be the, I don't know how many of the techniques you had kind of shared with in the reference notebook, how much of that he implements. But that might be a reason when he goes to large that you shared his batch size is down to 2. So you might get it up again by doing many of the techniques.
Abhishek,
yeah, but I think I will try batch size. Sorry, I will try batch size 2 because his score is quite good. So like maybe batch size 2 is like the good batch size here. I don't know.
No, that may be, but I was saying I don't know how many of the techniques of memory saving techniques he has in his notebook.
Right, I can't tell without like looking at it.
Maybe he has gradient accumulation hidden somewhere there. Like maybe his actual batch size is smaller, or I mean larger.
So according to that shell script, he he's not accumulate. He's a gradient accumulation is set to 1, but I don't know if he's using gradient checkpointing. Maybe he's doing it inside his TES package. I don't know. But from the shell script, he's not accumulating batches.
Okay, yeah, that's interesting. I never saw something like that, so that such a small batch size would work.
Yeah, someone also asked the same thing in the comments. I don't know. Guess we could try batch size 2.
Yeah, that's interesting. In my experience, something like 16 to 32 is often the way to go. So 64 is too much, but it's either 16 or 32. Yeah, interesting.
Yep, and you might also have to increase the number of epochs if the batch size is less, 16. So you got to have at least 10, I think so, epochs. If it's 32, then 6 epochs will do it well, I suppose.
Do you mean if you increase your batch size, you should also increase your number of epochs to train so that you have the equal number of updates?
No, increasing batch size is inversely proportional to the epochs. So when you increase your batch size, you can decrease the number of epochs there.
Can you?
Because in the number of training examples that your pipeline will take in will be kind of more at a given point. So your network is processing, your network or the model is processing more amount of how do I say it, the batch, the number of training examples. So that processing will reduce the number of epochs. It's like so if we have a higher processing processing examples, the number of examples are higher in a network. So the processing will be higher and the number of epochs can be made less based on that.
Okay.
Okay, anybody else have any other comments? Lots of suggestions, good discussion on various things to try and analyze. Let's see how much of it we can get done as the next week. Any other comments, anyone? If not, thanks for joining. Thanks for the interesting discussion. And we'll all meet again next week.
Yeah,
Good
see you
luck.
everyone. Thanks.
Thank you.
See you later.
Bye. Take care.
Bye.